Okay. Good morning. In the previous lectures, we talked about diesel injection systems. Okay. We talked last lecture we discussed the inline pump. Okay, and we knew how it works. It's very personal. And I just want to remind you with something about inline pumps that you have to remember before we start distributor injection pumps. Last time, I told you what are the functions of the plunger in the inline injection pumps. What were its functions? Pressurize, generate the high pressure, and metering the fuel. The third function for the pumping system was distribution. Did the plunger perform the distribution in the inline pump? No. What did we force the distribution in the inline pump? لا مش طيب ان كل cylinder ليه plunger خاص بيه one plunger per cylinder. Okay, so the distribution was performed as there is one plunger and barrel assembly per cylinder. Okay, now for the distributor injection pumps. You see, the shape of the pump is different from the inline. Okay? And if you look closely at this cross-sectional area, you will find that these are, see this is the delivery port, okay, which is the end of the pump that you connect the high pressure lines to. There is 1, 2, and 3, and 1 in the cut section, so 4 delivery valves and 4 outlets to 4 cylinders. And if you check the construction of the pump, how many plungers does it have? You see the components? There is only one central plunger for this pump. So the distributor pump has only one plunger per pump. Okay? So, again, what will be the function of the plunger for the distributor pump? It still have to pressurize. Okay? And it still have to meter. Okay? But now, because there is only one plunger per pump and per engine, so the plunger itself must do what? The distribution function. Okay? So the plunger's function for the distributor pump is pressurization, metering, and distribution. Okay? And to understand how does the distribution works initially, you see this slot here. Okay? This is a distribution slot. The plunger has only one slot for the distribution. Okay? So this slot rotates, and as it rotates, it gets in front of each delivery valve. So it distributes the fuel for each delivery valve. But there is something here. When the plunger rotates one rotation, okay, where does the distributor pump get its motion? it should get its motion, its rotating motion from the camshaft. Okay, similar to the inline pump. And the camshaft, we know it rotates at half the crankshaft speed for four-stroke engines. Okay, so for one rotation of the camshaft, the plunger will rotate single time. Okay, during this single rotation, it should provide fuel for all the engine cylinders. Okay, so if we have a four-cylinder engine, then the plunger must distribute the fuel 4 times during its single rotation. But in order to distribute the fuel, it must first pressurize it. Okay, so the plunger must perform the following for every injection. It must retract to perform suction for the fuel. Okay, and it must advance to pressurize the fuel. And the mechanic will be performed during this stage. Okay, we will know exactly how it's done. And it must, after it pressurizes the fuel, it must distribute the fuel to a single cylinder. Then it goes down. Intake fuel, go up, pressurize fuel, and rotate to inject the fuel to the next cylinder. Okay, and so on. If the engine is 4-cylinder, this process must be done 4 times per single rotation of the plunger. So if the engine is 6 cylinders, how many times should the plunger perform these functions per single rotation? 6 times. 8-cylinder engine, 8 times, and so on. So let's give the example that we always provide. If an engine is running at 3,000 RPMs, okay, single, it means it rotates 50 revolutions per second. So the time of a single revolution is 20 milliseconds only. Okay? And we know that so the crankshaft single revolution is 20 milliseconds. Okay? So what will be the time of a single revolution of the camshaft? What is the speed of the camshaft? If the crankshaft is rotating at 3,000 RPMs, camshaft speed is half the crankshaft speed. Okay? So it requires double. If it's half its time, if it's half its speed, it rotates in double the time the crankshaft. So a single camshaft revolution is 40 milliseconds. Okay? So if the engine is 4 cylinders, has 4 cylinders, so the plunger must perform to go down and intake fuel, go up, pressurize the fuel, and distribute the fuel every 10 milliseconds. Okay? If the engine has 8 cylinders, then it must perform this function every 5 milliseconds. And this is only at 3,000 RPMs. If the RPM goes higher than this, then the time available will be smaller. Okay? Due to this function, due to this phenomenon, the plunger can't supply fuel to an engine that has more than 6 cylinders. Because more than 6 cylinders, there will not be enough time for the plunger to intake fuel, pressurize it, and distribute it to each cylinder effectively. Okay? So the distributor pump can be used with a maximum of 6 cylinders only. Okay? And it's usually used with a small engines. Okay, and by the way, by small engines, it doesn't have to be small in size like as in my hand or a single cylinder or a small engine. Small engines, especially for diesel engines, are categorized up to approximately 200 kilowatts. Approximately up to 200 kilowatts, which is a quarter of a megawatt approximately, is still considered small engine for diesel engines. Okay, you know, 200 kilowatts is approximately 360 horsepower. Okay, it's a lot, but for diesel it's still considered small because diesel engines, okay, they can be used for power generations. Okay, and for power generations, I have seen diesel engines that has power approximately 1 megawatts. Okay, a diesel engine could be the size of all of this corridor. Maybe you know the width of this class. Two times its width can be the length of a single diesel engine. Okay, diesel engines for marine applications. The cylinder a tall person can stand inside the cylinder and dive in it. Okay, and a single bore or diameter of a single cylinder for marine applications can fit maybe 3 of us in it. Okay, so diesel engines can be very, very large. So when I say small engine, it's up to 200 to 250 kilowatts. Okay? The schematic diagram for the distributor system is still the same. The tank, the tank, it throws fuel through the filter and it goes to the distributor pump. First of all, if you remember when we talked about the fuel supply pump, okay? Let's remind you with it. Yes. The fuel supply pump. We said that it can be mechanical or electrical, right? And we said that it can be mechanical. It has the diaphragm type and plunger and vane types. We said the plunger mainly used with what? With inline injection pumps. And the vane type is mainly used with what? Distributor injection pumps. For the inline pump, did we say anything about the existence of the supply pump within the pump itself? No. The supply pump is a different unit that is added to the line before the high pressure pump. The supply pump delivers high pressure fuel, approximately 5 to 6 bars, okay, that fills all the cavities of this pump to perform cooling and lubrication and to make the fuel ready for the intake of the plungers. Okay, and it's a separate unit outside of the inline pump. Okay, for the distributor, if you check its schematic, do you see any mention of an external supply pump? The fuel goes from the tank to the filter directly to the distributor pump. Does it mean that the distributor type doesn't have a low pressure pump? No, it has a low pressure pump. But the low pressure pump is integrated within the distributor pump's casing. Okay? This is a cut section, a more cut section of the pump. The first part of the pump, okay, here is the low pressure pump, okay, which is a vane type, okay, and as the plunger rotates with the camshaft, And of course, the vane pump rotates around the camshaft, so we can install the supply pump inside the casing of the distributor pump. Okay? So the supply pump is separate for the inline and integrated inside the casing of the distributor type. Okay? Let's watch the video.
The distributor type pump uses a vane type transfer pump to fill the single pumping element. This then raises fuel pressure to injection pressure. A distribution system then,
From the shape of the front of this pump, how many cylinders does it serve? 4 cylinders. We have 4 delivery valves. Okay, so this pump serves 4 cylinders.
fuel to each cylinder in the firing order of the engine. The most common type in light automotive use is the Bosch VE pump. A drive shaft driven from the engine rotates a plunger and a cam disc. Cams on the face of the disc.
First of all, we said the first function of the plunger is to perform the pressurization. And we said that pressurization must be done, that the plunger must go down, okay, to intake fuel and go up again to pressurize the fuel. How can this be done? If you check these cam plates, see these cam plates? It has cams that must have the same number as the cylinders, okay? And they rotate over a roller disc. So whenever the cam coincides over the roller, the plunger goes up and pressurizes the fuel. When the cam passes the rollers and go down, the spring returns the plunger down again to intake the fuel. Okay? So this cam disc controls the number of injections per rotation. And it must be the same number as the engine cylinders. Okay? I have a question for you. The cam plate should have cams with the same number as the engine cylinders. Do we need to make the rollers the same number as the engine cylinders as well?
Yes. Yes. Yes.
Yes? Why?
Because when it go down, it will pressurize the release of fuel. So when we have many rollers, it will keep no function.
Okay. What if we have a single function, a single What if we have a single roller? When this cam passes the roller, it will move up, pressurize the fuel. When it will go down, it will intake the fuel. And the next cam will come and go up over the same roller and will inject the fuel again. Okay? If the 4 cams pass by the single roller, it will perform 4 different injections. Okay? So it will still perform its function. So do I have to have the same rollers number as the engine cylinders? I need to have it the same for just balancing. Because I need the plunger to just reciprocate horizontally. Okay? But if I have a single roller, when this cam goes over this roller, is there anything supporting the other cams? No. So the plunger, instead of moving horizontally, could tilt a little. And if any tilting occurred with this high rotating speed and very high oscillation, it could just break the plunger or cause excessive wear in its barrel. Okay? So we need to make the plunger move only horizontally, reciprocate only without any tilting angle. So we add rollers with the same number as the cams, so that when the cam plates go over the rollers, the whole cam plate is supported by 4 rollers and making its movement only reciprocating without any tilting. Okay? واصلة؟ حسك بتعمل كده.
It says cylinders.
شايف الحركة بقى بتاعته؟ You see the movement?
A plunger spring holds the cam disc against rollers that rotate on their shafts. The lobes move the plunger to and fro in its barrel, making it rotate and reciprocate at the same time. Its rotation operates the fuel.
See the movement of the plunger? It rotates to distribute the fuel and moves horizontally and reciprocates right and left to perform the pressurization function. Okay? Now, where does the fuel come from and where does it go? I told you that there is a slot in the side of the plunger. It was approximately in the middle. Okay? That distributes the fuel to each cylinder. So this is the distribution port. Okay? And when it aligns in front of this delivery valve, the fuel is injected through this to this cylinder. Okay? But where does the fuel come inside the system? You see this port? This is the intake port for the pump, where the pressurized fuel from the supply pump comes to be pressurized by the plunger. Do you see its passage opened? No, the plunger closes its passage. So how does it come in? You see this slot? Okay? This is one of the inlet slots for the plunger. When this slot aligns in front of the inlet port, fuel comes right in and fills the chamber in front of the plunger. Okay? When the plunger moves to the left and pressurizes the fuel, where does the fuel go? The fuel must go from this port to the delivery port. Okay? How does it pass from this to this? The plunger is hollow from the inside. Okay? And when it pressurizes the fuel, the high pressure fuel passes through the inner tube of the plunger and goes directly to the delivery slot and goes to the delivery valve. Okay? I need you to watch this part of the video again and tell me how many cylinders does this pump serve. Okay?
And
That's like the argument I was saying. We mentioned that there must be an inlet slot, okay, for each intake time. So let's count. This is the first one. And this is the second one. But you see that there is a difference in shape. The first one was a single slot. The second one, it's like U-shaped. Okay? The second one has ended. Now, the third one, which is also U-shaped. This is the third one.
Station on. Operator.
And you return back to the single slot. So how many cylinders does this pump serve? 3 cylinders only. Okay? Why is there a difference in shape for the inlet slots? It's just some design consideration. Okay? You do not have to worry about it. Okay? It's for a design consideration. They are all serve the same function. Okay? So now, and if you count during the rotation, when we counted the 3 inlet slots, the plunger rotated one single revolution. And during the single revolution, how many outlet ports appeared? Again, let's watch it rotate.
Or to the pumping chamber. And at the same time, distributes pressurized fuel.
2. Okay? But I need you to look closely. This one, it has a hole on the inside. While the second one,
Injector. Injector.
while the second slot, it's solid, it's closed. So how many delivery slots per plunger? Only one that has the hole inside. So what is the function of this other one? You know what its function? It's just, it passes, when it passes right now in front of this delivery valve, does it supply any fuel to it? No. You know what it does? It returns excess fuel or pressurized fuel from this delivery valve back inside the pump. Okay? In order not to cause what's called secondary injection. Okay? It releases the pressure in front of the delivery valve quickly in order not to cause what is called a secondary injection. Okay? So, for the single plunger, how many inlet slots does it have? Inlet slots have the same number as the engine cylinders. What about the delivery slots? Only single delivery slots. Okay, that distributes the fuel to each cylinder. ده تاني بص باختصار احنا عارفين ان الدليفري انا قلت لك ان فتحه الدليفري سلوت اللي فيها الخرم من النص تمام عشان ندخل الفيول على الدليفري بامب. طب انت بعد ما الدليفري فولت خلاص عملت الانجكشن والفيول طلع فيه، تمام؟ مجرد ما الدليفري سلوت ديت بعدت عنه، تمام؟ مش هنا متخزن فيه فيول بضغط عالي. تاني واحده واحده. بص اهو دلوقتي الدليفري اهو سلوت اهي قدام البورت ده، صح؟ فدلوقتي احنا بنعمل انجكشن، هتلاقي حتى في الوقت ده البلانجر بيطلع لقدام. كده احنا عملنا ايه؟ الانجكشن خلاص في الدليفري فالف ده. ايه؟ ده الدليفري فالف. ايوه مش احنا قلنا ان فاكر في الانلاين بامب المره اللي فاتت مش كان في وصلات فوق كتير كده؟ مش قلنا كل الوصلات دي الدليفري فالفز اللي هي اللي بيوصل عليها المواسير الحديد اللي واصله لحد كل انجكتور، صح؟ ده هنا نفس الوضع. ده هنا الدليفري فالف ده راكب هنا، اللي بيوصل عليه من هنا. مش انا لما وريتك وش البامب من الاول كان طالع منها 4 وصلات؟
بس هنا واحد.
ايه؟
هنا واحد.
ما احنا واخدين هنا كروس سكشن بس فيه.
ماشي.
احنا بنبص على كروس سكشن. يعني ده هنا واحد قدامنا. واحنا على ما عدينا كان البلانجر ده بيخدم كام سلندر؟ 3. يعني البامب دي كام سلندر؟ 3 سلندر بس، مش الاربعه حتى اللي هو عرضها لك فين؟ في الاول. تمام؟ فانت هيبقى عندك كام دليفري بورت من دول؟ 3. واحد هنا اهو، وهتلاقي واحد في الظهر هنا وواحد فوق، بس احنا مش واخدين فيهم كروس سكشن. اوكي؟ فاحنا عشان كده بنعرض اللي باين قدامنا.
كده واحد بيودي الدليفري، في اللي من فوق بيودي الدليفري، التاني بقى اللي بيطلع اللي هو الاسيس او الزياده.
بص التاني ده اللي هو ده اللي قصدك عليه ده.
ده الزياده؟
ما هو ده ما فيهوش الخرم.
ماشي.
فده التالت، ده التاني اللي هو من الجنب ده التاني. بص ده بالنسبه لنا ده ملوش لازمه، تمام؟ يعني احنا بالنسبه لنا الفانكشن بتاعي البامب ملوش لازمه، بس انا بفهم ده لازم ايه؟ ده لما دلوقتي احنا لما البامب عملت الانجكشن هنا، تمام؟ مش هنا متخزن قدام الدليفري فالف فيول ببريشر عالي، صح؟ انا عايز البريشرايزيشن او عايز الانجكشن يحصل وقت الانجكشن فقط، ما يكونش فيه اي انجكشن في اي وقت تاني. طب لو في بريشر فيول ببريشر عالي متخزن هنا، مش ممكن يحصل حاجه اسمها سكندري انجكشن، ان يعمل انجكشن صغير في وقت تاني غير وقت الانجكشن الاساسي، وده بيهدر لي فيول وبيضيع لي باور ما استفدش بيه، تمام؟ فانا بستخدم ان لما اعدي السلوت دي قدامي، انت واخد بالك السلوت دي مفتوحه على ايه؟ على ورا كده، تمام؟ يروح لو في اي فيول بضغط عالي من هنا يروح متسرب منها على ايه؟ على الكيسنج بتاعت البامب. يبقى انا كده ضمنت ان مش هيبقى فيه بريشر عالي جاي قدام الدليفري فالف الا لما يجي له من الدليفري بورت اللي فيه الفتحه من هنا وقت ما بديله الفيول. ماشي؟ لو انت متزاول فيها انساها خالص دلوقتي. انا بقول لك انت متزاول فيها انساها خالص دلوقتي. احنا المهم ان انت في دليفري بورت واحد لكل مين؟ بلانجر. تمام؟ اللي هو مخروق فيه الخرم ده جاي من الهولو سلندر اللي جوه البلانجر، تمام؟ من قدام لحد هنا يطلع على الدليفري فالف على طول. ماشي؟
The fuel in the pumping chamber. The plunger's pumping action forces fuel through a delivery valve to the injector. This pump is for a 3-cylinder engine, so it has 3 delivery valves.
خد بالك الثلاثه دليفري فالفز همت. ادي واحد اللي احنا واخدين فيه كروس سكشن، ده مش موجود اللي هو الوصله بتاعته. ودي الاثنين التانيين اهو الثاني، وادي ايه؟ الثالث. تمام؟
The barrel has 1 intake port and 3 distribution ports. The plunger has a central passage, a connecting passage to the distributing slit, and a cross drilling to a control sleeve. As the plunger rotates, each intake slit aligns with the intake port, and the distributing slit with the distributing port. As the plunger rotates, the intake slit moves away from the intake port. At the same time, the plunger is acted on by the cams, causing...
واخدين بالكم من الحركة؟ Check the slow motion. Now, at this moment, the fuel has already gone from the inlet port through these inlet slots and filled the space in front of the plunger. Okay? Now, further movement of the plunger rotation just blocked the fuel inlet, and the plunger moved forward to pressurize the fuel inside the chamber in front of it. Okay, where does this pressurized fuel go? Inside the central passage till it passes. لا مش ده. Till it passes to the delivery port and injects the fuel at the dedicated cylinder. Okay? And you see that now when it gets back, injection has finished. You need to start the intake for the next cylinder. The plunger moved back. When it moved back, the spring, the cam plate has just passed the rollers, went over the rollers, and the spring pushed the plunger back. Now you will see that the inlet slots, the next inlet slot of the plunger is currently opening to allow the fuel to pass from the inlet valve to fill the chamber in front of the plunger. You see this?
Causing it to move axially along the barrel, pressurizing the fuel in the pumping chamber. The distributing slit now uncovers the distribution port, and the pressurized fuel passes through the delivery valve to the injector. Further rotation of the plunger closes off the distribution port and opens the intake port. At the same time, the plunger spring moves the plunger back along the barrel for the next pumping stroke. For intake, fuel from the feed pump reaches the open intake port in the barrel. The intake slit aligns with the intake port, and fuel fills the pumping chamber and passages in the plunger. For injection, the plunger rotates to close off the intake port and moves along the barrel to pressurize fuel in the pumping chamber. The distributing slit aligns with the distribution port, and the pressurized fuel forces the delivery valve off its seat and reaches the injector. In this phase, a cut-off port in the plunger is covered by the control sleeve.
Okay, till now, we only explained two functions of this pump: the pressurization and the distribution. Did we mention anything about metering? No, we didn't mention anything about metering. From the movement of the plunger, the same thing we said for the inline pump. The reciprocating movement of the plunger, is it constant or variable? Constant. Okay? So the actual stroke of the plunger is always constant. So we need to make it in a way to have an effective stroke. Okay? That part of the fuel gets injected to the cylinders and the remaining part returns back to the casing of the pump. How is this done for the distributor pump? We mentioned that the distributor, the plunger, is hollow. And this hollow passages has the delivery port, okay? And there is another hole after the delivery hole.
The fuel delivery plunges back in the delivery valve injector, or the plunger rotates to clogging chamber. Off the barrel, same pivoting slit, Pumping chamber rotates the throttle of the pumping rotor and the pumping tool and the pumping chamber, and the pressurized fuel injector by the control sleeve. And across.
This is the shape of the plunger. You see it has the delivery slits and the inlet slots, and there is this hole at the end. This hole is still connected to the inner passage of the plunger. Okay? This hole is covered by this cooler. This is called the control cooler. Okay?
Moves out of the control sleeve.
You see, when the plunger moved forward to perform the pressurization, you see this slot? It appeared from under the control collar. Okay? This is the return slot for the high pressure fuel in front of the plunger. Okay? When the plunger is moving forward, it pressurizes the fuel, and the delivery port just injects the fuel into the cylinder. When the plunger moves forward enough so that this return port is uncovered from under the control cooler, where does the fuel go? Does it go to the high pressure injector, or goes back to the low pressure fuel inside the pump's casing? It returns back to the casing of the pump, to the low pressure part. Okay? So how do we control the amount of injected fuel? By moving this control cooler axially, we can control the injected amount of fuel. If we move this control cooler to the right, then the return port will appear earlier. Okay? So the amount of injected fuel will be small and the return amount will be larger. If we move the control cooler further to the left, it will uncover the return port later. So the injected amount of fuel will be larger and the return will be smaller. How do we control this control cooler? This control cooler is connected to the accelerator pedal. When you press the accelerator pedal, you move the control cooler to the left. When you depress the accelerator pedal, the control cooler moves back to the right. Okay? Let's continue.
Pressurized fuel spilled back into the pump housing. This relieves pressure in the pumping chamber, the delivery valve closes, and injection ceases. Metering the fuel is controlled by effective stroke of the control sleeve, and that's determined by the action of the
movement of the control cooler
sleeve along the plunger.
It's moving right and left
opens the cutoff port early
according to your
and reduces
the accelerator pedal distance.
Sliding it this way delays its opening and increases effective stroke. The governor changes the position of the control sleeve to vary the quantity of fuel delivered according to throttle position and load. When the ignition is switched off, an electrical solenoid.
Till now, is there anything that is vague? Do you need to ask about anything? Okay?
The function of the cooler is to fuel metering.
Yes. controls the fuel metering. This is the third function of the plunger. The plunger itself controls with the control cooler, controls the metering of the fuel. Okay? So there is a question now. If you remember the last lecture, according to the shape of the helix of the plunger, the inline pump, we said that some shapes control the start of injection, and some shapes control the end of injection, and another shape controls the start and the end of injection. Okay? For the distributor pump, do we control the start or the end of injection? The start. When does the return port open? Is it at the beginning or at the end of the injection? At the end of the injection. So for the distributor pump, always the start of injection is constant. The end of injection is only controlled by the movement of the control cooler. Okay? انت مش مريح.
استوعب
يعني فاهم لحد دلوقتي طيب
مش
ولا؟
فاهم دلوقتي بس انت ازاي بتغير.
هو انت دلوقتي بتنهي الانجكشن ازاي؟ هنا. مش الانجكشن بينتهي لما الضغط يقل؟ صح؟ طب انت دلوقتي البلانشر بيطلع لقدام بيرفع الضغط. امتى الضغط بيقل؟ الضغط يقل في حاجتين. لو البلانشر ابتدى يرجع لورا تاني، تمام؟ او الفيول لقى سكه اسهل يروح لها بدل ما يروح لمين؟ للانجكتور. تمام؟ الدليفري فالف، خلي بالك الدليفري فالف ده اخر البامب، واصل بعد كده الهاي بريشر لاينز اللي هي الميتال لاينز دي اللي واصله للانجكتور. يعني من الاخر السكه كلها رايحه لمين؟ للانجكتور. فامتى الفيول اللي ببريشر عالي ينتهي؟ زي ما قلت لك يا البلانشر يرجع ورا، يا اما ان في سكه سهله الفيول يلاقيها يروح لها بدل ما يروح للانجكتور. طب السكه السهله دي بتتفتح امتى؟ ما الكنترول كولر، تمام؟ دي بتتفتح في بدايه الانجكشن ولا في نهايته؟ في نهايته. يبقى انا كده في الديستريبيوتر بامب انا بتحكم في بدايه ولا نهايه الانجكشن؟ في نهايه الانجكشن. البدايه كل مره مالها ثابته، لان كل مره اول ما البلانجر بيطلع لقدام ببتدي الانجكشن. انا بنهي الانجكشن اول ما الريتيرن بورت يظهر من تحت الكنترول كولر. تمام؟ ده كده منظر الاستراكشر بتاع الديستريبيوتر فيول بامب. تمام؟ انت عندك في البامب 5 اجزاء، يعني البامب دي اللي انت شفتها متقسمه 5 اجزاء اساسيه. ده كان في حته في الفيديو اخيره كنا عايزين نشوفها.
The distributor type pump diesel and load. When the ignition is switched.
For the diesel engine, we mentioned that the combustion starts by self-ignition due to the very high compression ratio. Okay? How do we turn off the engine? When you switch your key from the car stops. Okay? This is easy for gasoline cars because when you switch the key off, you disconnect the electricity from the battery to the whole vehicle. So electricity is lost from the spark plug. So there is no spark, so the car shuts down, the engine shuts down. But what about the diesel? Does diesel require spark? No. Okay. So how does turning off the ignition key shuts down the engine? If you turn off the ignition key and the engine is running, So the pump is rotating with the engine, and injection of the fuel is going. Okay, so you have no way to shut off the engine. In order to shut off the engine, you need to cut the fuel. Okay, so how do you cut the fuel?
An electrical solenoid closes off the intake
This is the
port and
electrical
stops
solenoid.
fuel delivery.
You see this movement?
And low. Solenoid closes off the intake.
This is the electrical solenoid. Okay, you see that it's near the delivery side. Okay, when we go back,
And
this is the plunger. This is the electrical solenoid. Okay, this is the inlet port to the plunger. When you cut off the power, the electric solenoid shuts off and moves down to block the inlet of the fuel to the plunger. So when you block the inlet of the fuel, there is no more injection and the engine shuts off. Okay? So we have 5 main ports for the distributor pump. Port number 2 is the main port that we just explained in the video. It has the cam disc, the cam plate, and the rollers. It has the plunger, okay, and the delivery port. Okay, this is the main port. Now, port number 4 is the shut-off valve that we just explained. The electromagnetic shut-off valve that cuts the inlet of the fuel. Okay. Port number 1 is the vane type fuel supply pump. I told you that the fuel supply pump for the distributor is encased within its main casing. Okay, so the vane pump rotates with the cam shaft that controls the movement of the plunger. So the plunger and the vane of the fuel supply pump all rotate at the same speed, and they are all controlled by the cam shaft movement. Okay? Now remains parts 3 and 5. Okay? Part 3 is called the mechanical or speed governor. Okay? You don't need to know exactly how it works, but according to the speeds of the camshaft and the engine, okay, you need, for example, if the speed increases, the available time for combustion decreases. Okay, so you need to advance the injection. Why you need to advance the injection? Because fuel still needs time to evaporate and mix with the air and start the combustion. Okay, and with higher speeds, this available time is smaller. So you need to inject the fuel a little bit early so that you can give the fuel enough time to combust. Okay, so this is speed governor. You see these weights. Okay, these weights, when the speed increases, it just move out. Okay, and they control somehow the injection timing. You do not need to know anything more about it. The fifth and last part of the distributor fuel injection pump is the timing device. Okay, the timing device, you see that it controls this. It controls this rod. Okay, you see there is something like a piston here. Okay, that controls this rod. This rod is connected to what? You see it connected to the rollers, the roller plate that allows the cam plate to move over it and perform the injection, the pressurization. Okay? And you see that this piston is controlled from this line. This line is from the low pressure supply line. As I told you that we need, as the speed changes, we need to change the injection timing. Okay? This is controlled partly by the mechanical governor, but the main part is controlled by the timing device. Okay? How can I know that the engine speed has increased? There is a very simple way that we can use with distributor pump. When the engine speed increases, the crankshaft speed increases, and the camshaft speed increases. The camshaft drives the supply pump. Okay? If the supply pump's rotation speed increases, what happens to the pressure? It increases. So the increase of pressure moves this rod that rotates the roller plate. If the roller plate rotated, if this roller plate number 2 rotated, okay, from this rod, okay. For example, if you pulled the rod in our side, okay, so it will have an angular rotation of the rollers. So it will make the cam plate meet the rollers slightly earlier than required. Okay, I won't show it again. Now, you see that the port number 5 here, it is the piston that controls the roller plate. Okay? If the pressure increase drives the foot on the right, see that this rod moves slightly left and it rotates the roller plate slightly with an angular rotation. Okay? This makes the cam plate meets the roller slightly earlier. Okay? And starts the injection earlier. If the engine speed reduced and the pressure is reduced, this springs returns the rod back and reduces the increased angular rotation of the roller plate. So the cam plate meets the rollers slightly later and returns the injection time back to its original time. There is something called injection lag. Okay? What is injection lag? Injection lag is the time between the generation of the pressure wave at the pump and the start of the fuel injection into the cylinder. The start of the pressure wave generation inside the pump and the start of injection inside the cylinder. What is the difference between this time? This is the time that the pressure wave that is generated inside the pump moves through the delivery valve and through the high pressure pipes to the injector to open the injection and the injector to make it start the injection of the fuel. Why is this injection lag important? Because time equals distance over velocity. And the pressure wave generated always moves at the speed of sound. Okay, so the velocity is always constant. So what controls the time? The distance. This means that all the pipes connecting all the cylinders from the pump to the injectors must have the exact same length. Okay? If a pipe has a shorter length, then its time will be, its injection lag will be smaller. So it will start injection early in this cylinder, earlier than the other cylinders. The same if the pipe was longer. Okay? We learned previously that there is something called the ignition delay period. Okay? The ignition delay period is from the start of injection to the start of combustion. The injection delay is preceding the injection delay. The ignition delay. There is injection delay and an ignition delay. Injection delay starts first. It's from the start of delivery to the start of injection inside the cylinder. Then after that starts the ignition delay period, which is from the start of injection to the start of combustion. Okay?
This is the timing device. This is just a general comparison between inline and distributor for your information only.
The distributor pump is still purely mechanical pump. Everything is controlled by either pressure difference, speed difference, centrifugal force. Now, if we want to improve the performance of the pump, we introduce the electronically controlled distributor fuel injection pump. Okay? We just replace some parts, the parts of mechanical parts, with electronic parts. For example, we add some sensors and actuators that are controlled by the ECU. Okay? For example, we can replace the control collar just from being moved directly by the accelerator pedal and to make an actuator that controls its movement. Okay? So that we can control the opening and the closing of the cutoff ports and control the amount of injection fuel electronically. Okay? And the timing device, it is controlled by the fuel pressure from the fuel supply pump. We should remove the timing device overall. Okay? And add a pressure sensor that senses the pressure of the engine, or add even a speed sensor that senses the speed of the engine. When the speed increases, okay, we control the rod of the roller plate by an actuator. If the speed increases, then we move the roller to advance the injection. If the speed decreases, we return the rollers to return the injection to its predetermined time. Okay? So we just, in the electronically controlled distributor fuel injection pump, the same pump, just still the same, just we remove some mechanical components, okay? and replace them with sensors and control the movements by actuators to improve its performance. Okay?
خلينا